Now we're going to do a really exciting problem. We're going to do a problem that involves the washer method where we're not revolving around the x or the y axis. So we're going to revolve around another line. So our question says, find the volume of the solid generated by revolving the region bounded by x equals y squared, x equals 1, about the line x equals 4. Now, we always draw the picture, so here's our axes. If we want to think of graphing this, if we solve for y like we're used to, we'd have y equals, we'd take the square root plus or minus the square root of x. So this isn't a function because it doesn't pass the vertical line test, but we get this part and this part. It's basically a parabola turned on its side. Now x equals 1 would be the vertical line where 1 is. And we want to revolve it around x equals 4. So that's 1, 2, 3, 4. We're going to revolve it around this line. Now, let me kind of clean this up a little bit so that we just see what we're revolving. If we kind of get rid of the rest of this function that we don't care about, we just care about the region of the intersection. So that's this shape. Okay, so we're taking this and we're revolving it around this, which means we would get a piece over here that looks like this. And if you can picture what this would look like if you spun it around, you'd basically have an inner tube, or a donut or something, with exactly a cylinder cut out of it. So it wouldn't be exactly like a donut. It wouldn't have nice round edges. It would have this cylinder straight line cut out of it. So let's draw one cross section here. We see that would be our outer radius, and then the washer comes because we'd have this hole. Now, one thing to notice is our center is no longer at 0. Our center, even though my picture isn't perfect, is here at the line x equals 4. So we're going to have to keep that in mind when we define our outer and our inner radius. Now, the other thing to keep in mind is since we're revolving around a vertical line, this is going to be a problem where we integrate with respect to dy. So everything we're going to need to think of vertically. Now, to find where these two intersection points are vertically, we're going to set, since we've got x equals 1, we're going to put that in for 1 here. So we can even do it in our solve thing here, y will equal plus or minus the square root of 1, which will just be plus or minus 1. So we're going to go from negative 1 to 1. We always have that pi out in front when we're doing our disk or our washer problems. Now we need our outer radius. Now our outer radius goes from 4 out to, let me see if I can get a different color, from 4 out to our y squared. So what that actually is, it's going to be 4 minus y squared would be our radius, and then in our formula we square it. And then our inner radius is just the 1. Let me get a different color. Our inner radius is going to be from this line to the 1, so it's just going to be 4 minus 1, which is 3. So we're going to have minus 4 minus 1 squared. So we can clean this up a little bit before we integrate it. We're going to have that pi out in front, the integral from negative 1 to 1, 4 minus y squared squared, which you could just FOIL that out, minus 3 squared, so that'll be 9 dy. So if you integrate this integral, which is not hard to do, we get 136 over 15. So our final answer would be 136 pi over 15.